Hello and welcome to Xamarin University. My name is Adrian Stevens, and today I want to talk to you about preparing your mobile applications for publishing. Now, once you've developed your application, you're starting to think about publishing it to the world, there are several steps you'll want to go through to ensure your application is ready for your end users. And the things we'll talk about are platform independent, and much of this advice would apply really to any application you want to distribute. So let's talk about polishing our applications, and a big part of that is focusing on quality. Our users have a really high expectation for their mobile applications, and if your app looks and behaves poorly, your users will simply switch to another app. And a big part of that is image quality, so make sure everything looks fantastic. Make sure it's crisp and sharp in every resolution. Also, try and make use of the platform-specific features. Take advantage of those cool features that make each platform unique and special. A great example of this is iOS's 3D touch. Use animations to draw your users' attention to areas of importance. Point out your key features and show your users that you've spent the time, you put in the effort to make an amazing UI. Of course, always make sure your app works on all of your supported devices, and make sure that your UI scales across these different screen sizes. Localization can be really important, and make sure this is done well. It's a really great way to help expand your user base, but you want to make sure that you're respecting the languages and the cultural differences. And of course, testing. Test your app exhaustively. Make sure it's as bug-free as possible, and test those edge cases. Look for all the mistakes your users might come across and try and get to them first. Now, taking the time to add translated content for other languages in your application can be a huge competitive advantage. Users, of course, prefer apps in their native language, and for some applications, they're not usable if they're not properly translated. And this means that without translations, you can be excluding a large percentage of your users. And of course, language is so important to some countries and cultures that surveys show that people will pay more for localized apps versus a lower priced English-only competitor. Now, most mobile app stores will test your application before it's published to their app store. When your app goes through the review process, if it crashes or behaves incorrectly, it's an automatic rejection. Now, this is true of most of the app stores out there, but even if it wasn't, users won't tolerate bad applications, and it's a sure way to get uninstalled. So make sure to test those edge cases, things you hope don't happen often, but will happen periodically. And so what happens when you don't have a network connection, or if it drops out unexpectedly while your app is communicating with a server? What's the performance like on an older device? Are you still testing on that old iPhone 4? What happens when the user enters bad or even malicious data into your application? And does your app properly respond as the device is rotated? So as part of your testing, consider creating some UI tests to run your app through its functionality with Xamarin UI Test. This is a free framework, and it lets you automate your UI and drive it just like a user would, and then even verify that proper screens are hit, that behavior occurs, and that the UI updates as you expect it to. You can then push these tests along with your application up to Test Cloud or Visual Studio Mobile Center and run it on a wide set of physical devices with different form factors, different OS versions, and even different capabilities. And this is the same sort of testing that vendors often do before allowing your apps on their store, and you'll often find interesting, even subtle issues that you didn't expect, particularly when trying it on different screen sizes. Now, with this testing effort, it can be very helpful to get reports on how your application is being used and any problems people are having with it. And this is the role of analytics, and there are several really great reporting engines out there. In fact, each of the three vendors we're going to talk about, Apple, Google, and Microsoft, have analytics engines that you can integrate, and they'll give you app statistics and even crash information. Now, Microsoft has an analytics engine, and it's cross-platform, called Hockey App, and we really recommend you use that one because it integrates really nicely with the Xamarin tools and the Xamarin runtime. So app crashes will get a full managed stack trace to really help you identify and zoom in on those problem areas in your code. Alright, so you've tested your application, you've polished your application, and you're ready to build your package that you want to distribute. And there's 5 things you want to think about. You want to create an optimized package. You want to double check all of your visual resources. Make sure that all your images are sized properly, you've got high-res versions, and all the correct meta images are included. If this is an update, make sure you got your version number, your version information set correctly, and then of course it's been updated from the previous version. You want to compress your app as much as possible, and we can use something called the mono linker for this. And then of course you want to build the actual distribution package. So here's something developers don't always realize. Your app actually runs differently when built for release versus debug. So make sure you always do your final testing on release builds, and make sure you submit the build that you've tested. And when you're doing your testing, test on physical devices, because it often changes how the compiler and the runtime generate code. This is based on the processor and the architecture. In addition, verify you've got optimizations turned on. This should be on by default, but if for some reason they've been turned off, or if you're including debug information, then make sure to reset the optimization settings. And keep in mind that all app stores today will reject builds that contain any debug information. Now, your app icon is often the first thing that a user sees when they're browsing the App Store, and it's what draws them back to your app once it's installed. So generally recommended to make it simple, meaningful to your app, and make it eye-catching. Ensure that you're also including multiple versions of your icon to support different resolutions. Especially make sure you're adding the high-resolution assets so your app looks crisp and amazing on the latest and greatest devices. And be sure to include other metadata like splash screens, and if possible, even display an animation if your app takes a long time to load. And this will make that load time feel shorter and let your users know that your application is continuing to load. Now, versioning, very important for both you and your users. So many software developers use both major and minor versions when creating updates. So major versions, major updates are usually reserved for significant changes, launching a new killer feature, or a build that includes significant app-wide improvements, or maybe even changing the compatibility for devices, maybe new OS versions. Now, increasing the minor version is often done when you're adding small features or making incremental improvements. And when you're submitting updates to the app stores, you'll be required to increment your version number. Now let's talk about linking, and this is the process of removing unused executable code. Now by default, if you use a single type from an assembly, your application will include the entire assembly in your output folder. Now this has happened for a long time, and in the desktop world, we don't really worry about this too much. We've got lots of storage on the desktop, and also because a lot of the .NET framework is likely pre-installed and shared. In the mobile world, we don't get to share things, so everything needs to be included in your application package. So if you use types from several different assemblies, your app gets big really fast. And now this is where the linker comes in. Mono includes an open source optimizing linker named Cecil, and this is capable of removing types and methods that you're not using. And it does this by analyzing all of the code paths in your application, makes a list of everything, every method, every field that you're using, and then gets rid of the rest. And this process is actually kind of similar to what the garbage collector does with in-memory objects. Now, this optimization can have a dramatic impact on the size of the resulting app, typically reducing it to even half, maybe even smaller. Now, note that Microsoft has its own optimization techniques for Windows, which are for the most part done in the store download process. This part isn't relevant for Windows, but is mostly for iOS and Android. Now we've got three options available. Now the first, don't link, do nothing. All the assemblies that you're referencing are simply added to your application package. Now for debug builds, this should be the option you choose as it's the quickest compilation type. However, this also generates the largest application package, as you can probably imagine. Now, by default, release builds always link the SDK assemblies. Now, these are the framework assemblies that have the .NET framework and the runtime. Now, this switch includes what we refer to as safe to link assemblies. These are assemblies that have an assembly level attribute applied to them, which indicate they should be evaluated by the linker. And this almost always works just fine, because the specific assemblies the linker examines have been built to ensure that the necessary code is always preserved. So you should, at a minimum, always link the SDK assemblies. And by link, I mean remove the parts we're not using. and this will reduce your application package size. Now, if your app package is still too large, there is another option, and we can actually reduce the size further. And this last option is to tell the linker to scan all of your assemblies. Now, this is the most dangerous because the linker can be very aggressive and sometimes will remove things that your code actually depends on but wasn't explicitly referencing. However, it's also the one which will drop your package size down the most, particularly if your app has a lot of non-SDK assemblies or a lot of third-party assemblies. Now, we've seen apps that will drop the size from 70 meg down to 20 meg, 70% reduction in size can be really, really significant. But again, make sure you test that final release version that has the assemblies linked out. Now, this option is controlled in the project options under the build tab for either iOS or Android. And we see the Android dialog here. And you see the linker behavior. We can choose don't link, link all assemblies, or our safe version, link SDK assemblies only. Now, if you create framework assemblies that are shared, then you can include your own assemblies as part of that SDK set that are considered safe. Now, this is done by defining a custom attribute named linker safe attribute. Now, this is part of the runtime. It's in the iOS Android assemblies, and you can simply define your own version to avoid taking a dependency on the iOS Android runtime. Then you either use the built-in iOS Android attribute or your own, and then the linker will look for that name, the linker safe attribute, and it can be in any namespace. And this, again, just tells the linker to include your assembly in that SDK list. And this means that your assembly will be linked, have the size reduced when using that safe linker setting. So to maximize our reduction, we can change the linker behavior to link every assembly. This is going to walk through every bit of your code and remove anything you don't have a direct reference to. This includes your own code. So if you have some utility DLL or even methods in your own classes that don't appear to be called, the linker will remove them. Now, this sounds a little bit dangerous. The linker can only work with what it sees, and in complex applications, we will often use abstractions or other techniques to hide the final implementations. And these sorts of things can hide a reference from the linker, and then you end up with a program that doesn't execute because it doesn't have all the classes, all the fields, all the assemblies that it actually needs. So there's a couple of things we can do to manage this. First, we can tell the linker to ignore a specific assembly or a set of assemblies by listing them in a comma-separated form on the linker options tab. And this just will let you link the majority of your app, but ignore some critical assembly or one that doesn't link safely. Now, if you want to get a little bit more fine-grained, you can provide hints to the linker through two mechanisms: attributes applied in your code and a linker directive file, which is written in XML and provided to the linker during the compile process. Well, let's look at both of these. The first approach is to go through your class and add a preserve attribute to types that you know you need. And this is what has been done to critical types in the SDK assemblies. The linker interprets this attribute to mean the type must always be included. Now, when you apply it to a class, you can also set a property all members to have it preserve not only the type, but all the fields, all the methods, and all the properties. Now, if you want to preserve the entire assembly, maybe it's a core data assembly, you can simply put the attribute on the assembly itself as shown here. Now, if it's just a specific field, a specific property, or a specific method, you can just put the preserve attribute right on the definition itself. So as an example, here we might not be referencing ID in our code directly, but we still want that field to be created in the database and therefore want it in the class definition. Probably a good idea. Now, it's very likely that you're using a PCL or a shared asset project to hold your shared business logic. So the preserve attribute is actually part of the core Xamarin assembly. And it's actually unavailable to portable class libraries, but it is available to those shared asset projects. So to allow you to use this in PCLs, the linker specifically looks for this attribute by name only. Now that means that you can define your own PCL version of the attribute as shown here, and then apply it to your classes and members, and the linker will respect it. Now the namespace is not important. The linker simply looks at the name of the attribute. Now, all members, which you saw earlier, it's used when the attribute is applied to the type itself, and conditional this allows you to say, keep a member only if the type itself will be kept because of a direct dependency. Now, our second approach is to create a linker configuration file. This is an XML file that you'll add to your project, and this lists the specific assemblies, types, and operations that you want the linker to ignore, and again, ensure they're kept in the final produced binary. Keep in mind that you only need to list things that you don't actively reference but want to keep. So hard references to methods and types in your code will always be preserved. Now, to use the linker XML file, you add it to your project as an XML file and then set the build action to be link description. Now, the format of this file is well defined and allows you to take as much control of the process as necessary. Now, it always has a root tag of linker and a set of assembly children. Now, in the assembly section, you can specify a full name or partial name for each assembly that you add to this file. So here we're telling the linker to keep the app.core assembly, and this will match any assembly by that name. Now, within the assembly tag, you'll list the types to keep, or as you can see here, you can tell it to keep all types through a wildcard. You can also add type tags for specific types. For example, here we want to keep the main page type in the app core assembly. Now, an optional attribute on the type tag tells the linker to preserve every field in the type, and by default, it will preserve all operations since none are listed. And you can preserve types through the namespaces that they're defined in, and this keeps every type declared in the specified namespace. And finally, you can be very specific about the operations using the method and field tags. So if you have an overloaded method, you can specify the signature instead of the name. And again, you can see that here on screen. Now, going through the steps to reduce the size of your assemblies can have a dramatic impact on your app package, and it's highly recommended that you go through these steps, especially for larger applications. But it can be a little bit tedious. So here's just a workflow to follow. Remember, this is for the release build, and if it's an iOS app, make sure to use a real device for testing and use the iPhone configuration so it compiles the app to native code without jitting. With Android, you can use an emulator as long as it executes the same code as the real device. So, set your linker options so to include all assemblies. Create a linker XML file, add it to your project, specify that the linker should preserve all of your assemblies, and then use the references in the solution to know what assemblies to add to the file. And then add a global type inclusion so the linker preserves everything in each assembly. Now, run your app on a device and test all aspects to make sure nothing is missing. And it should work because we're not throwing anything out. So if you're hitting a bug, there might be a bug in your code. It's probably not from the linker. Now, remove one assembly from your linker file so it's included by the linker. This will dump everything out of that assembly that you don't directly use. Now run the test again. It's helpful to do this in the debugger so you can see exceptions, but the iOS diagnostic log and Android debug log will show exceptions as well. Now if you're lucky, everything continues to work, but if the linker got a little bit too aggressive, you'll get a runtime crash. Now most often this will either be a type initialization exception because it threw an entire type away, or a missing method exception because it got rid of a called operation. So now you want to identify that missing type or operation and then add it to your linker configuration. And then of course, we're going to repeat that process until you've gone through all of your assemblies and your app continues to run as expected. Now once you've got a compacted application, you're ready to create a distribution package. Now, these are often zipped containers with your application and all of its assets. Now, each platform does this a little bit differently, and really the best way to stay up to date is to check the documentation from each vendor. There are also excellent guides on developer.xamarin.com. Now let's talk about the publishing process itself, and there are 3 different ways to distribute your applications. First, you can distribute them directly to your customers. This is often called ad hoc distribution or side loading, and Android supports this type of distribution without any restrictions. Apple and Microsoft, however, only allow this distribution style for testing, and they limit the number of devices you can deploy to with this approach. You can also distribute your applications through a publishing store, and this is typically what you think of when you say you're going to publish your mobile application. This is of course the most common approach and provides for both commercialization as well as really broad visibility since it's marketed by the vendors themselves. And finally, you can distribute through an enterprise model. This is designed for internal use apps within a corporate structure. So for example, a computer manufacturer might build an app to manage their warehouse inventory and distribute it on their own internet to their own employees. Now for Android, this is the same as ad hoc, because Google doesn't have any restrictions. There's no limitations on private distribution. So you essentially just self-sign your app and distribute it, via website or directly to the devices. Apple and Microsoft, however, use this as their supported mechanism for distribution outside of their public stores. So both require that you obtain an enterprise certificate from their publishing portals, and both of them require you jump through, well, there's a few hoops, there's a few things you need to go through to get an enterprise license. Now, Apple in particular, they're very reluctant to give these out because it lets you bypass their store, and therefore it cuts down on their profits and it really reduces the use of the App Store. Now, the store model is the one that most apps will use, and each vendor has their own branded store that you can publish your app to. And the vendor will market the app, they'll provide access to it from compatible devices, and they host the binary, they host any marketing materials, information that you supply, and this allows users to find your application, maybe by keywords or by category. Now, in terms of app stores, Google and Android are by far the most open. There are over 100 different app stores for Android. And these stores vary. Some focus on specific geographic locations, some even focus on specific app types or app categories. And if you support Android, then you'll probably want to consider distributing your apps to multiple stores. Usually we start with Google Play, it's the most popular. Amazon is second, but you want to look at other stores like GetJar, CNET, and Get5. And then again, even digging deeper if you're localizing your application. Now for Apple and Microsoft, each have a single app, and it's one-stop shopping. It's the only place to buy applications legally. Now, before you publish to any public store, make sure you read through the publishing agreement. This tells you the rules they expect you to follow, as well as any content guidelines for what's considered acceptable. Now, each store has a different set of requirements, and some are more strict than others, but generally speaking, you want to avoid anything illegal. Hopefully that's obvious, but it is frowned upon in the app stores. You want to avoid using internal or undocumented APIs. Most of the vendors really frown upon that. Make sure your content matches age restrictions. This is especially important for games and entertainment. You want to avoid any pictures or depictions of real violence. And if you enable hidden features after the testing process, that could be grounds for having your app removed from the App Store. Now, looking at published content on the app stores, Google and Apple are very close. Both have over 1.5 million apps in their store, and this is based on marketing data from mid-2015, so expect these numbers to be higher now. And you can see the other app stores, well, they've got considerably less applications. Now, this gives you some idea of popularity. You see Windows is behind in the number of apps. However, this can also be interpreted as an opportunity for new developers. It's a good place to get a foothold in the market, and it could mean less competition within certain app categories. Now, Google, Apple, and Microsoft all require you to register as a developer before you can submit apps to their app store, and each one has a registration fee. Now, take a look at the numbers on screen. These are in US dollars, and if we look at the iOS App Store, it's $99 for a regular developer or $299 for an enterprise developer. And these are annual fees. These are recurring fees that have to be paid every year. Google, in comparison, has a $25 one-time fee, and then you're a member for life. And it's the same story for Microsoft with the Windows Store. It's $19 to join as an individual or $99 to join as a company, as a corporation. And there's some other interesting numbers here as well. Both the iOS App Store and the Google Play Store have no limits on the number of apps you can publish. For Windows, you're limited to 100 free applications, but there's no limits on paid applications. And you can see the market share numbers here as well. Although Google Play has a much larger share than iOS, there's actually more money, typically more revenue generated on the iOS App Store. Windows is a bit smaller, and they have a smaller market share, but again, could be seen as an opportunity. Now, when it comes to enticing your users, you want to grab them early and get them to download your applications, get them to try it. And so that means things like your icons and your screenshots, all your marketing metadata on the store, very important. So make sure it looks great, of course. Now, every store has that publishing data you can include with your binaries. You need to describe your application. You can do things like provide videos, show your application in action. This is actually required now by Apple for iOS 8 and newer. You need screenshots. You want to show off your application, show off those key features, show off those great screens, show off your amazing UI. Of course, come up with a catchy name, something that describes your application, and a detailed description of your features. Make sure that description matches your application. If it doesn't, it's possible you will not meet the requirements of the App Store and you won't be published. And of course, you want to include SEO keywords. This is used for the search engine so people can find your application. And don't underestimate these steps. The icon, the screenshots, the first things your potential buyers will see. Make them compelling. You want your users to, at minimum, be interested, if not outright impressed at your quality. Right? So spend some time. Think about how to best show off your app. Know your audience. Know the category. Know the market that you're trying to appeal to. And, tailor your app, tailor your description, and tailor your screenshots to those users. Now, once you submit your app to be published on the App Store, it's going to go through a review process. And this process is not instant. It can take, between 2 and 10 days. And that actually depends on, of course, the App Store, but also the time of year. And for example, holidays can be a little bit slower. Now, Apple tends to be a little bit pickier than Microsoft and Google, and their rules have changed over time, and they've even sometimes been subject to the reviewer interpretation, meaning, a second application, you might pass on something that was flagged by a previous reviewer. Microsoft tends to be a little bit more lenient, but they've been very picky about things like localization. So if you start the localization process, you add a second language, you need to localize the screenshots and make sure your descriptions are completely localized along with all of the features. So Microsoft's really going for completeness in that respect. Now, once your app is reviewed, you'll get an email indicating if it's been published and available or that it was rejected, and they'll give you really good descriptions, really good reasons as to why your app didn't pass. And if it's rejected, there's no penalty, so don't fear this step. Take the feedback, change your application, perhaps make a fix, and resubmit the application. And I've heard stories of people submitting 5, 6, 7 times. There's no penalty. You don't get blacklisted. So just go ahead and make the changes, and off you go. Now, part of publishing your application is determining a revenue strategy. Now, not all applications are designed to make money. Sometimes you just want to share something with the world. Sometimes it's part of a broader publishing or branding strategy. And some applications are just designed to make money. But make sure that you have realistic expectations. A lot of applications barely break even these days from development costs. Again, people are expecting great applications. It takes time to develop. And even really popular apps will eventually stop making as much money. They'll fall off the charts, and that revenue will slow or even stop. Now, statistics say that, roughly speaking, you want to be in the top 250 to 500 apps to be making much money. And remember how many apps are on the App Store. This is not necessarily an easy thing to do. So publishing an app does not mean an instant path to riches, but doesn't mean it can't be part of your successful business strategy. But keep this in mind when you're pricing your application. Think about your competition. Do you have something unique? Do you have a corner of the market that only you own? Well, that might give you room to sell your application for more. But if you're competing against other similar applications, you want to make sure that you're priced reasonably. Now, another option for generating revenue is to provide advertisements within your application. And all of the app stores support ad revenue, and it's generally fairly easy to bring this into your application. And this makes a lot of sense for free applications. It's a great way to generate a little bit of revenue, and as your app gets more popular, then more revenue may come in. There's a lot of ad frameworks out there. Each vendor has their own. There's a lot of third-party, and many of these are cross-platform. So actually, as an example, you can integrate Google's AdMob into iOS using a Xamarin component. As well, another popular option is to use in-app purchases. This can be a really effective strategy if you have a free app with advertisements. You can use this to remove the ads or add additional app features. It's really great in games. You could use it to add additional levels or provide help to pass a difficult level or add extra items. And some apps will also use this to transition from a free or reduced price version to a full version of your application, almost like that old shareware model. You want to be a little bit careful though. You don't want people to feel like they're being asked constantly for money. So if you ask them to pay for a low price version and then you're constantly upselling, this could actually generate bad reviews. But if done well, can be a really popular and really successful revenue strategy. And this brings us to the end of our presentation here today. Thank you very much. I hope you enjoyed our presentation on publishing your mobile applications. Again, my name is Adrian Stevens, and I hope to see you in a live class very soon.